on Kickstarter, I've had 2 projects. It's raised about $25,000 so far off of those 2. This is the series that I'm sort of working to get towards. So I started out with neural networks, and I wrote a couple of books on neural networks back starting in 2005. Neural networks are great. They're one of the many sort of gateway drugs into artificial intelligence to get you into other things. Neural networks have gone in favor, out of favor. Deep learning is really bringing them very much back into favor because that's one of the 2 big sort of ways that data science is being done now. Deep learning is particularly used for pattern recognition for robotics and computer vision and that sort of thing. So I wanted to get more, sort of expand that into AI so that I wasn't constrained just by neural networks and I could do whatever I really wanted to within AI. So I did volume 1 earlier, and currently I am working on volume 2. And volumes 3, 4, and 5 may very well change by the time I actually get to them. So what is Kickstarter? Kickstarter is basically a way to raise, it's sometimes called angel investment, sort of your very, very first stage of starting something. So maybe you want to create this really cool electronics project, but you need to source it to a factory overseas somewhere, and there's just a lot of startup costs. So what you can do is take your pitch to the world, let people see that, and they will back you if they like it. And that basically lets you get your seed capital just to get those first prototypes out the door. And then very often, people on Kickstarter attract bigger investments and can go on to just continuing with the whole startup sort of process. And there's some important aspects to the way that Kickstarter works. Projects must make their goal or it fails. So I set some amount that I want to raise. And if you don't make that amount, the theory is that's the amount you needed. So everybody gets their money back and you get nothing. That's very disappointing for certain projects. And backers are pledging this money in return for rewards. The rewards might be a product, or in some environmental cases, you just get a sticker saying, hey, I supported this. There are some important rules in Kickstarter that have had tragic results when people don't follow them. Do not back your own project. That's a major no-no. I'll show you why. You must meet your funding goal. If you don't, you get nothing. Even if you miss it by 50 cents, you get nothing. Once the project ends, delivery or not, that's not Kickstarter's problem anymore. So if you get $1 million from all your backers and you say, thanks, I'm leaving the country, not Kickstarter's problem. If you don't fit into these, Indiegogo is another popular choice. Indiegogo, you can say, oh yeah, I realize I needed $1 million, but if it gets 100,000, yeah, I'll just wing it, which is kind of an interesting idea. So here are some just quick examples, and I've just got some slides here to get you, just to show you kind of what I'm talking about so the rest of this talk makes sense when I show you how I'm analyzing these. Projects must make their goal. This was actually a really cool game. People my age might remember something called Mule, which was done by Ozark Software right here in Missouri. Kind of the same idea, not the same guys. These guys wanted $50,000, and boy, they just missed it by like $28,000. This is not what you want to be famous for, but they are. That's kind of the case, the hardline case of you got to make the goal. They even talked to Kickstarter of, can I just write you a check? But no, they only missed by $28. Now, why you don't want, now this one, actually my data analysis, because I'll get to this more later, but I basically wrote a scraper that got a bunch of Kickstarter data. So I have 120,000 projects downloaded that I have access to. And this one popped up as a major outlier. It did not make sense to my program for various reasons. If you notice, they've got $60,000, but 86 backers. This is why you don't back yourself. This is why they don't want you to back yourself, because several of these backers was this guy and his friends and relatives who were basically, there's many conjectures on that, so I don't want to necessarily give them a bad name for different things, but they were canceled by Kickstarter for violation of backing your own project. At 86, and people backing this for 500, 600 to 10,000 more than he was asking for, they're afraid, and I'm not saying that's what they were doing, but they're afraid that you are basically upping your amount so that new people coming in say, oh my gosh, $60,000, they are rocking and rolling, I'm gonna get on that one. The other thing that was interesting about this too is this is actually an artificial intelligence project. And what they're selling is basically this guy is saying that over his senior high school summer, he wrote a AI assistant on the level of Jarvis, of Iron Man, that computer assistant. I don't know, maybe not. So that was the project. Another one that was also AI. This is an example of it got funded, but now they're not delivering it. This was also an AI project. Totally a cult book, but if you've ever heard of Super Toys Last All Summer Long, it's very much about artificial intelligence, and it's the basis of the Steven Spielberg movie AI. These guys are currently fighting over whether anybody gets anything. This was a very famous one that beef jerky, basically you're going to take the finest meat in the world and make beef jerky out of it. I'm thinking maybe the Duck Dynasty people, but I don't know. So that was just an absolute fraud. So they got canceled. This one was kind of interesting. Basically $120,000 he made for a board game. And then he just said, after he got the money, canceled, sorry, I don't have time. So he's currently got the internet mob tracking him down. So anyway, Kickstarter analytics. So since I'm showing how to analyze Kickstarter, there's other things that do this. And I want to show you some of these and why I took it beyond what they were doing in directions that were interesting to me. So there's KickTrack and KickSpy. KickTrack is really neat. That is kind of like the Google Analytics. If you use Google Analytics for websites, that's like the Google Analytics of Kickstarter. And then KickSpy, that was based on an academic paper, and this guy has kind of continued it. So prior research, don't reinvent the wheel. I did look at prior research because I wanted to see what other people had done. If you want to look at Kickstarter data, Vincent Etter, he does have some data that you can download on Kickstarter for his project. And then the second one, I also made use of some of the data in here. And I think the pizza has arrived. Let's see, do we want to just take a brief pizza break while everybody gets pizza? Okay. Need the All right, think we can go ahead and continue. So like I said, these are the two primary papers that I found out there, and I read both of them, and I made use of some of the data that was in these, as well as try to look at their results and try some of my own models and improve upon that. So that's part of what I will be talking about. And I also went in a somewhat different direction than the first one, and I will explain that. So KickTrack. This is my first project on KickTrack. My project absolutely blows that paper's model, and not intentionally, and nor am I particularly proud of that. It's an outlier. If you look at basically the funding levels of my project over its 30 days, something very significant happened about 3/4 of the way through. So the first paper basically tries to predict where you're going, if your project is going to be successful or not, based only on the funding level that it has over the first 3 or 4 days. So the amount of money that you've made over the first 3 or 4 days is a great indicator of how the project's going to be. What really happened here is I didn't know a whole lot about Kickstarter at the beginning, and along about 3/4 of the way through, somebody kind of helped me figure that out. So I'll explain what happened there later when we get to the very end, because I do actually I will actually discuss the steps that I think you should go through, at least this week, it's ever evolving, to take one of these to where you want it to go. And to where the type of product that you have is going to support going. So this, for example, there's a lot of models that people use on Incog where they want to do currency trading. So they'll be looking at the US, the USD to Euro rate, and they're looking at that as it goes up and down and does what it does. They're looking just at that alone because they believe every other piece of information in the market is factored into that price. So they're trying to predict trends as it moves around, and that's exactly what this is doing. This does not care about how much promotion you've done or how much press releases or who's mentioning you. They figure that's all factored into your funding levels at the first 3 days. So how much money have you secured in those first 3 days? What does the shape of your curve up to a certain point actually look like? What I don't like about that approach, and that's great for if you're evaluating a lot of Kickstarter projects and you want to know which one's going to succeed and which one's going to fail. That doesn't do anything to help you make yours succeed. Because what does that say? That just says, okay, make a lot of money in the first 3 days. Great, how? So that's one of the primary ways that I wanted to build upon that particular article. And it's just different goals. He was trying to predict more as a observer. That's like if you analyzed all the billionaires and used net worth by their age to predict how likely somebody is to become a billionaire. That doesn't tell you how to become one. That just tells you if somebody's likely to or not. Otherwise, the instruction would be have a net worth of 10 million by 25, or whatever it would happen to be, which doesn't really help you. Leading and lagging indicators, essentially. This is the second paper. I found this one a lot more interesting because this was more along the lines of what I was doing. I'm very interested in unstructured data. Unstructured data is basically data that is not in a database where you can just go query across it. Wikipedia is one big giant hunk of unstructured data. Some of it's semi-structured with the tables, but largely unstructured. Vast amount of knowledge in Wikipedia that can be used just getting to it in a way that the computer can understand. So what this was a relatively simple analysis, but what they were doing, this is almost a Wordle. I don't know if you've seen Wordles where, should have probably brought an example of that, but that's where you take a giant block of text and you basically do frequency counts on the words, essentially a histogram, and then each word has a size based on how often that word happens. So if you've got unstructured data, that's a real quick and easy way to just get a look at it. This is like that, except the sizes indicate frequencies, but it's showing you that pledgers will is a very common phrase in successful Kickstarter projects. Pledgers will receive, in particular, is very common. So people want to know what they get, which somewhat makes sense. Pledgers will, and then it breaks off. So it shows you all the branches. So this is a very good way to analyze, this sort of a diagram is a very good way to analyze a lot of sentences. And sentences are very much unstructured data. They make a lot of sense to us, but try to write a program to extract information from them. You're in natural language processing now. So anyway, this is what that paper found out from there, just a variety of interesting things. Reciprocity, they want to know what they get and what it's being used for. Scarcity is very important. That's one that I don't probably do as good on. But you want to give them a reason to get in there and support the project. And these were all things that the author of that paper found out by analyzing lots of Kickstarter projects and analyzing the text in them. Whereas the first paper was more interested in the numbers behind it. And I'll show you actually what model they used in a second. So in data science, because that's sort of what I do for a living. I'm an informatics scientist, so I do a lot of analysis of underwriting data. So how long will people live, and are they a good bet for life insurance? If I was a hypochondriac, I would have the worst job in the world, because all these medical codes for different extremely bad things that can happen to you. So you always want to know, before you're analyzing the data, what do you want to know? Now, sometimes sometimes the data will tell you things that you never even knew you were interested in, but it's good to have some goals. So this is what I was particularly interested in. What is the best way to promote a publishing Kickstarter project? Now, the two highest grossing things on Kickstarter are video games and technology. Now, technology, that's misleading, because technology, and both of those two are really misleading, because it is expensive to produce either of those two items, a video game or some sort of electronic device that you're going to give to your backers. You've got to figure out factories and sourcing and all kinds of stuff. And then the amount that you make per pledge is as your pledges go up, you're shipping more items. So the multi-million-dollar amounts that you see on some of those technology projects, that's not pure profit to these guys. They have to still mass produce this thing and get it out to you. I was very curious about goal amount. So goal amount, should I set it high and make people stretch for it? Should I set it to truly what I just need and let people exceed it? Because you don't stop when you hit your goal amount. That's all right. It just keeps on going. So what some project creators do is they create stretch goals where they say, okay, we've hit what we asked for, but let's keep this going. And they keep upping the ante and providing additional things. That's my approach. I figure out exactly what it costs to create this book, what I really need, and I put it on there. And then we try to exceed it, and usually they do, fortunately. What's the best reward mix? And then this is one that I've thought of too. I've written books, I've published them. Does perception of need have anything to do with this? So I was concerned, will they look at this and say, well, he's already self-published several books. Why is he doing a Kickstarter? What is this? Does need actually matter? And then, like I said, the last thing, what else am I not thinking about? What can the data teach me? And when you find stuff in the data that you weren't even looking for, you have to be really careful. There's two words that are often used, which is correlation and causation. And famous saying, correlation does not imply causation. Correlation is when you see, oh, this one thing changes. It changes again. This other thing changes. That's not necessarily that it's causing it. It could be, and that can get you in a lot of trouble, and it's difficult to determine. So does need actually equal success? This would be a case where it doesn't. Spike Lee, and people take flack over this, but this is an example of where somebody who's very famous, I don't think he would have too much of a problem pitching creating his next movie to a production company, but he chose to go on Kickstarter. And his fans were very supportive of it. So there's a number of different cases of this where these projects were, in fact, he got about 200,000 more than he actually asked for. So I want to take you through the process that I did to analyze this data. This is a very famous diagram. I mean, how else is a data scientist going to represent what they do? With a Venn diagram, of course. I mean, these are used to analyze data. So what a Venn diagram does is it shows you how things overlap. So where you have math and statistics, you have substantive experience. So that's, do you know anything about the data that you're actually analyzing? And you have hacking skills. So programmer stuff. If you basically have hacking skills and you have substantive experience, that's the danger zone because you're missing the sort of statistical analysis. If you have hacking skills and math and statistics, that's machine learning because you don't really care what the data even means. You just want it to converge. You want to predict the inputs using the outputs. And you can go on to UCI, University of California, Irvine. I've definitely done this many times just to test out models. You download data. The data actually means something. It might be analyzing breast cancer. It might be looking at forest cover. I don't really care. I'm just trying to get my model to converge as I'm testing something new. So that's just pure machine learning. And substantive experience, that's traditional research because you didn't really use the hacking skills. So I'll show you how I go through all three of these. And different data scientists are better at different areas. I came up through programming, so obviously hacking skills and just that sort of thing is where I started. So hacking skills, let's start with that. So what I basically did is I scraped 120,000 pages from Kickstarter. Do they mind? We'll get to that in a moment. But this is basically, often you have to go get your data because the data may come to you in a nice Excel sheet. For me, it certainly does not. What I do in my day job, I get all these statements from doctors and APS reports and all kinds of semi-structured and unstructured data. So that's not to be underestimated, just getting your data. I also wanted to focus on external information. So Kickstarter, okay, that's fine. There's data on Kickstarter, but what's happening outside of the world of Kickstarter? What backlinks do these pages have in particular? And we'll get to that in a moment. A language that is very popular, that is very rapidly becoming popular in data science is Python. I use Python for this just to get some additional experience with that language. Python is interesting. It's a glue language. It's got all of these statistical models, largely which were written in C and C++, that are extremely fast, and then it sort of lets you use them all together. And then I used a MongoDB database, which is very cool. It's highly unstructured and just lets you, it's document-based, so you can just stick the data into there and go with that. For what I was doing, where I'm just analyzing a lot of web pages, Mongo definitely did what I needed. For the analysis, I use Python, R, Pandas, which is kind of the intersection of R and Python. That's really cool. Numpy and Scipy. Numpy is numeric analysis in Python, and Scipy is scientific analysis in Python. And then I used Wikipedia data for additional analytics, which I will get to in a moment. So hacking skills. First of all, when I say hacking, it all depends on the color of your hat, which can be black, white, or gray. So you don't want to do, there's good hacking, there's bad hacking, and then there's, I don't know what kind of hacking I'm doing, which is, for example, does Kickstarter mind you actually doing this? There's a lot of sites that do that. KickTrack does. They haven't said, hey, go ahead and do a denial of service attack on us, which, by the way, I don't hit them with a lot of threads. So they kind of don't say to do it, but they don't really say not to, and they don't really shut down these sites that are clearly scraping them just hour by hour. And that's another important distinction too, is my data collection was just point in time. I grabbed only successful projects. I did not watch them as they grew because that was a lot more intensive. And that's kind of what that other paper did. So I didn't want to duplicate that. I was looking at what links are coming in and what does the project do? Now the problem with HTML scraping, it's extremely fragile. Now, Python's beautiful soup makes it relatively easy, but I guarantee you my code will not work a year from now. It will be utterly broken because they'll make one change to their site and now I can't find this tag and it's dead. That's part of the reason I have not uploaded my code for this, because as soon as you put it on GitHub, people are maintaining it. Oh my gosh, your code is broken. It will not download from Wikipedia anymore, or from Kickstarter. And I probably don't care by that point because I'm on to the next project. So this is all just quick sort of stuff that you throw together to get the data that you want. Now, Kickstarter, like I said, does not, they seem mostly to be okay with that, but not everybody is. So I was interested in external data. So who is linking to your site? Because that's extremely important. Those are called backlinks. They're very important in SEO, which is search engine optimization. Google has kind of beat up on people for this a little bit. The Panda update to Google virtually shut down a few sites that one day we're getting a couple million visitors from Google. The next day we're getting nothing. Huffington Post did not like that day. Google and Yahoo used to, so basically I need to get my backlinks. You cannot do this unless you're a search engine. So I know my URL. I want to know who's linking into me. You need to have the entire data of the web to do that. There's no way that I can do that, not unless I write a program to crawl every site. So you need a search engine to do that. You can just go to Google, type link : and the site that you're interested in, it will show you all of their backlinks. So I need to use a search engine to do that. You do not want to scrape Google or Yahoo. They get very mad. Very, very mad. So they used to provide this data for free, but they don't anymore. They have since found out that this data was really valuable and people would pay for it. So first Google shut down that capability and then Yahoo later. And if you do mess with Google, this is what you see whenever you try to do any sort of a search. That is not a screenshot from my computer. I have never ticked off Google from a personal computer. Maybe once on an Amazon EC2 node, but that's another story. So an Amazon EC2, by the way, when you're doing a lot of these is great because you can just bring up these nodes of extremely expensive computers. I can use a computer with 240 gigabytes of RAM. I mean, if I would love to build that and put that in my basement. But unless that thing is running constantly, I would feel so bad. And it doesn't. I just spin these up for a little while and then they're done. So Bing, the search engine. They are actually very good for this. I'm not really that fond of Bing for just about anything else. But for this, they're good. Mainly because they will sell you this data. So you can basically submit JSON queries to them. They give you the first 5,000 for free. So yeah, I'd just go create 20 accounts. I don't know. No, I didn't say that. And I wouldn't do that. $100 buys 50K more searches. So Bing is very good for this. And I did only pull the links for the publishing projects because that's what I'm interested in. And the other projects have a lot more projects in them, other categories like games, and I don't care as much. So I did the backlink analysis mainly on my own stuff, publishing. So these are basically some of the data that I was pulling from Kickstarter when I was scraping them. So I pulled the succeed or fail, I pulled reward levels for the backers, funding period, project goal, all of this stuff. This is structured data. Then I went, so structured data is where you've got a number or you've got some value. You know what it is. You can query this and you can say, select sum from this, where category is this. It's SQL. It's easy to do analytics on it. Unstructured data is the project. So all that text that the people typed in. How do you query against that? Select star from project where something. You can't. It's just big blocks of text. And it's hard to search those. It's how Google made a fortune, finding us the web pages that we're interested in. And I also checked how many repeat backers, because I'm doing this series of books. So I'm interested in, does doing project after project cause your backers to go away? Do they care? What? That doesn't seem to matter from some projects I've seen. And then I also grabbed the unstructured data, which is the project description. I did not grab the project video. I don't even know what to do with that from an analytics standpoint. I mean, maybe some deep learning, but geez, I don't even care. So the video, all I care about is the length, by the way, about 4 minutes. That seems to be the optimal. And then I cared about project updates because I care about what's going on as the project goes on, because I want to know. I'm not interested in predicting what other people's projects are doing. I want to know how to guide my own. And then I looked at the text to describe rewards. And unstructured data is hard. So time series analysis. This is what some of the other ones did. They did the time series analysis. They did I mainly did point in time analysis. I didn't want to have to sit there and scrape. Oh, has somebody else backed? Has somebody else backed? And then you have to figure out, I didn't want to do that, especially since other sites or these other papers had already done that and given me the research that I was interested in seeing. So this is a really fairly simple way that first paper did the analysis. So this is stuff that I actually do cover in the first volume of my series, the fundamental algorithms. It's got a lot of formulas going on there, but it's really not that complicated. So this is k-means clustering. So what they're doing is they're saying, we want to predict a project up to whatever point it is. So maybe it's at day 7. So we're going to look at all the projects up to day 7. So we're going to look at everything on Kickstarter up to day 7 because we want to compare this other project that is up to day 7. And we essentially calculate, it's called the Euclidean distance, between the project that we're comparing and the other projects off in Kickstarter space. Now, Euclidean distance is the distance between 2 points on a flat space or in 3 dimensions. Or if you're looking at 7 days, 7 dimensions. So you get into high dimensionality a lot in this sort of thing. So it's essentially so you're just looking at how close are these patterns to other projects. So this first one, all that's doing is you can see basically we're taking the money, that's what M stands for. So money at index I, which would be 1 through 7. So we're summing them, that's what sigma is, over that entire set. And all we're doing is we're taking the difference between the project we care about and the other projects, and we're squaring it, Pythagorean theorem basically, just in higher dimensions. and then we take the square root of the whole thing. And that's basically the distance between, that's how similar one of your projects is to one of the other projects. Then that second formula, that's just an average. That's why we're taking 1 over k. So we're summing again. F is the success of those other, so we find maybe the 7 nearest projects to you that had a similar 7-day curve, and we're basically just saying, okay, what are the nearest projects to me, and what was the average of their success rate? And that gives me an indication of if the project that I'm comparing is going to succeed or not. They've since moved on to somewhat more complex algorithms, but that's kind of how Amazon and some of the others started making suggestive sales to you. They look at customers that in whatever dimensionality they have, for you it would be gender, age, and other dimensions, who's close to you in this high dimension space and what are they buying? So this is called a KNN classifier, actually KNM, it's a typo, K nearest means classifier. They also use something called a Markov chain. Markov chain is kind of interesting as well. I'm not going to take you through all of the math for that. It would take about 3 slides, but essentially what you're looking at is states. So each of those days of the project is a state, and then the different funding levels is another state. What is the probability that you're going to move from one state into another? And it becomes this big matrix. And then you basically calculate you create this matrix over the entire of Kickstarter, and you can predict what the probability of moving to the next one is. So they used a separate, they compared both of these. Really, the Markov did not get a lot more data or a lot higher prediction accuracy than the simple k nearest means. So, for example, this shows their prediction accuracy of those two models, the Markov versus, I did have that slide right, I just forgot it wrong. It's k nearest neighbor, not k nearest means, sorry. That is the name of that algorithm. So basically, the baseline is another paper they were comparing against. So they were showing how massively they beat that one, which they did. And as you can see, as you go further to the right, that's time. So once you get to 1.0 on both sides, that's the project's 100% done and it's over. Well, you better be able to predict 100% at the end of the project because either it succeeded or it failed. So that's why it gets more accurate as you get deeper into the project. So you can see the curves are a little bit different, but mostly pretty close between the KNN and the Markov. Now, what I did to get a little bit better results than they did is I did not like the way that they were just feeding the actual funding levels into the comparison. There was no normalization whatsoever. The problem here is, and you run into this when you're looking for technical analysis in Forex and stocks and that sort of thing. Okay, one stock is trading at $5 a share, another is trading at $25 a share. You're looking for certain patterns in the like dishes and dishes with handles on them and stuff like that. The fact that they're at completely different price ranges means that it would be completely different patterns for both of those. So you kind of need to normalize those into a better, so that you're just looking at the percent change or something, so that a big number doesn't overwhelm a smaller one, because a lot of Kickstarter projects have very similar curves. This is very common sort of curve. You see an initial burst at the beginning, some completely plateau, some keep building, and then there's sort of a burst at the end. These two projects have relatively similar curves, not exactly, but one's at 33K and the other's at 2 million. See, these graphs normalize it, and normalization becomes very important in this sort of thing. Graphs are great at normalizing that because These are worlds apart in terms of the amount of money, but you can see the same sort of pattern. So that was some improvements that I did to that. Then you've got outliers, like me. Who is the idiot that put this one together? So basically, what I did here is I relied just on my followers. Yeah, they did real good for me. No, I loved my followers. But they were only able to take it to a certain level. And then one of my followers posted it on Hacker News. And it went somewhat Reddit and whatnot viral. So you can't, I'll get into that when I show the actual steps that I go through on that. But followers are very, very important. So if you're doing this kind of thing, blogging, that sort of thing is good, but not completely required. So those were some of the things I tried to do. Minimize biases so that big projects don't overwhelm. Look at the structure of the graph. And I was interested in many external sources of information, the links and that sort of thing. I also have been experimenting a lot with, this is kind of my current area of research, is affinity mapping to Wikipedia. And I'll show you what I mean by that in a little bit. So those are basically the sites that showed up as major contributors to publishing projects. The bottom two are actually probably the most important two. Domain-specific blogs and domain-specific forums. The board games people do amazing things with this on Kickstarter. I have to admit, I did not know that. I thought board games had probably died out a couple of decades ago. I was wrong. There's a lot of things that make a lot of money that I do not understand at all. And that's one of them. And it is actually kind of cool. But there's a lot of blogs dedicated to these board games, and if you can get the word out on those, you can have board games make. There is one actually in St. Louis going on right now, Viniculture, which is a wine-making board game. It's at about $250,000 right now, and it's only about 5 days in. So board games, they can do a lot. Like I said, I don't have to get it for it to make a lot of money. So this is what I was looking at as far as how to analyze this. So what I like to do is I do like to use Kickstarter data. It's not that huge compared to the size of hard drives these days. And what I am trying to do is make sense out of, so with some of the medical data that I look at, I use this sort of technique a little bit. Like I said, I'm just starting to experiment with this. But what I try to do is I have a document like a Wikipedia page, or I have a document like a Kickstarter project, unstructured data. I don't even know what this project is. What is this project about? Is this a AI book? Is this a green pair of socks? By the way, that was a very successful project. And so I need to know what it is. And what I've done is using deep learning, using a variety of different things, and using WordNet, which is very useful. That's a Princeton project. That's a huge hierarchy map. It'll tell you mouse is a type of animal, animal is a type of whatever, and it all ends in entity. So that lets you very quickly be able to make some natural language processing sort of inferences. So what I am basically doing is I am creating an algorithm that does a whole variety of comparisons between that project page and every page in Wikipedia. That takes a little while. Not too bad. Not as bad as you would think. About 10 minutes, I think, for an individual project. So this is where you'd go Amazon EC2 it or make your code more efficient if you wanted to do this for everything. So I did do it for quite a few publishing projects, and I found that whatever page it links to, first of all, does give you an idea of what sort of project that is. So my algorithm for comparing, what I wanted to do is, if I give it a Wikipedia page and a Britannica page, I want that to score high, because it's about the same thing. And then I look at the edit hotness. Edit hotness, that's my own term. I don't know. There's probably some way to describe that. But Wikipedia pages are constantly being edited. Well, certain pages are edited more than others. That shows you which pages are evolving technologies, which are currently in the news. It's an indicator. It is a correlation. I don't know if it's causation yet, but it seems to be. So I found that pages that using various versions of my page comparer algorithm, whatever Wikipedia page you had and I take the top 5 or so, you have the most affinity with, and if they're being edited a lot, that means that that's a good indicator of the success of that project. So I've read a number of papers on comparing documents because I find that very cool. Just what is the similarity between these two documents? I don't care about understanding it. That's even harder. That's IBM Watson kind of stuff. But I would like to be able to say, okay, like I said, maybe Tom Sawyer and the Wikipedia page about Tom Sawyer, they should score higher. A lot of research for here is for plagiarism detection. So professors like this, okay, are they plagiarizing? I mean, is this original? Let me go compare it against the whole internet. And there are engines that do that for you. And then this is where I do actually use a algorithm similar to in my current book that I'm working on, Genetic Programming, where you're actually evolving a tree that is essentially the program. So it's sort of ensemble training, but I'm adjusting it so that I don't want to be heavy-handed and tell it how to classify these articles because, one, that would be really hard, and two, that's machine learning. You want it to figure out on its own. So, for example, I would want the article on the United Kingdom to be dissimilar to the United States because they're very different, but yet they would have a lot of the same words in it. So that's some of the trick in getting these various algorithms to work together to do what I want them to. And I could do an entire presentation just on that. So that's why I'm very early in my research of figuring out how I want to do that. Okay, so kind of the last part of my talk is I really dislike when basically I read an entire paper on how somebody is using machine learning to, I don't know, predict when you should buy the USD EUR currency thing, and I've read the whole thing, and then the last paragraph says, oh, but by the way, this is just for educational purposes. I would never try this with my own money. Well, there went an hour of my life that I am never, ever getting back. And you do learn things from that, and I realize there's legal reasons why they say that. But this is basically Jeff's Kickstarter strategy. People who make a lot more on this kind of thing, so take it for what it is. But this is what I figured out in my data science of looking at it, and then this is also what I kind of came up with in terms of the substantive knowledge of just, I've ran these projects before, this is what I know about the data. You don't want to ever take human intuition out of it. So I always do a realistic attainable goal amount. I would love for my book to make $100,000. That would be really cool. I'm not going to set it as the goal because that's not what I need. I will do things to try to encourage them to take it well beyond my goal. A short, high-impact video is the best, particularly showing them what you're going to actually do. Kickstarter does have something called Project of the Day. There's all kinds of stuff written on Project of the Day. I really don't focus on that. It would be interesting to see what the analysis is of that. Basically, the Kickstarter staff gets together every morning and votes on these. Often what I think they are is usually they're projects that are not already funded, and the Kickstarter people think they are really, really cool. Why is this not getting any money? Sometimes they'll put them as Project of the Day and they'll still not make it. Sometimes they'll go viral at that point. I And plus, I just don't know that nothing against Kickstarter, I just don't know that Kickstarter is going to get what I'm even doing. So that's why that's not a goal. I do a multi-stage launch to it. That's why I've got the Saturn rocket there. Because, you know, pieces of that break off as they're done. It's not just a shoot the thing with a big slingshot. And then have an interesting enough project to stay, or basically you want to try to get on that front page rotation. I did some analysis on that. It's actually kind of interesting how I think, and I stress think, projects get there. And then having an interesting enough project to actually stay there. So, stage 1A is reach out to your followers. Followers are very important. They are people who you're connected to on LinkedIn. They are people who follow your Twitter feed. I have my stats there. That is not astronomical at all. It's good, but it's small. I mean, what's Justin Bieber at lately? But anyway, so yeah, it's really funny when they talk about that. It's like clout scores, like a clout score of 100. That means you're really important. You're somebody like Barack Obama or Justin Bieber. So that's interesting, the correlation there, not really causation. So that's me. So those will get you, and followers are good, and you're giving them, and it's a two-way street. I'm giving them useful information so they remain followers, and I send this information to them, and usually that will give me an initial sort of burst at that. And you definitely want to make it about what they're getting from it. Just don't say, hey, here's my Kickstarter, give me money. No, here's how this relates to all my previous information. Here is what this does for you. I would really appreciate your support because that's cool that they're helping you. So you don't want to ever diminish that. Stage 1B. Now maybe you don't have followers. Well, if you do want to be doing a Kickstarter, you should probably have a blog or something about what you're going to be doing in the future. But if you don't, that's not the end of the world. Stage 1B, which I do next, is hopefully within 24 hours, 48 hours, these guys have gotten you to a certain level so that there's at least some buzz around it. There's some comments, there's some money there. You post it to the social media. For my sort of project, Reddit and Hacker News are useful. There's a lot of debate. Should you post your own thing to Reddit? Should you post your own thing to Hacker News? That's hotly debated, and usually I prefer that. But you don't want to orchestrate. One thing that really ticks Reddit off, and I've never done this, but I've seen people do that, is where you have something viral going on your own site, and you say, hey, the next people that give me an upvote on Reddit, we're going to send something to. They do not like that at all. That's bad. Don't ever do that. And then D-Zone's kind of useful too. I did post this one to Reddit. The last one I did not. I was not punished for that at all. I got quite a few upvotes and participated in the comments. And Hacker News, that's actually what started my first one. So what I did on my first Kickstarter project is about 3 weeks between stage 1 and 1B, but I hadn't even defined this yet. I was just experimenting, learning. And then this is really kind of interesting, and I've written programs that monitor other projects as they go up and down, and this is time series, so I'm checking this as it goes. You basically, if you think about what Kickstarter is doing, and I have this on the next slide, that's the home page of Kickstarter. That top thing is project of the day, bottom is popular. That is really important to get there. If you think about it, all this real estate, and by the way, there I am in spot 2 on St. Louis, but all this information, all this space is extremely valuable to Kickstarter because they get a cut of it. So this is where they're doing their data science. They want to pick the projects, I don't know this for sure, but I would assume they're a company, they want to maximize their profit. They want to put whatever projects on this page that are going to actually generate the most amount of revenue. So what they seem to do, which is very interesting, is you would tend to think that that popular page, unless you get really, 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 it's just impossible to break into. But that's not the case. You will see they actually put projects into there temporarily and just test them out. You'll see them show up, they disappear. This is what they're doing this week. Might be different. This is pure observation using scrapers. And when my my first project, Kickstarter or Reddit and Hacker News, got it into the popular and it stayed there. And that's where I'm thinking 30 days. Okay, if that would have been, if you look at my graph, it was just going at a straight trajectory and then it hit a hard stop. So I still like the 30 days, mainly because I don't know that I would want one of these going on for 60 days from just a personal standpoint. But in that case, it would have been useful for it to been there longer. My second one, the genetic algorithm, I saw it pop up into there a few times. It just did not get the same traction as the first book. So that's why it's making right around half, I think, of what the first one did. But and I'll get to that in a moment. So anyway, that is the two projects side by side. If you just do a linear correlation, which is basically where you extrapolate point in time 1, point in time 2, I'm doing really bad here. So 18,000 on my first project, woohoo. I cut it in half for the second one. Boy, if I really do this right, I can maybe hit $4,000 for the next one. So that's the straight linear extrapolation. But it's sort of a learning process. So, and not every book in a particular series. So the second book did not have sort of the staying power on the popular page. It had, in terms of the data that I observed on Reddit likes and all that sort of stuff, it went through almost exactly the same curve as the first book, but things in artificial intelligence come in and out of favor. Nature-inspired algorithms, which is what this one is, there's some interesting research. There's a paper that I read, a dissertation paper from somebody here actually at Washington University who works for Google now, Moshe Locks, but it was the Moses system. Pretty fascinating. But genetic algorithms are sort of, I view it as a step. I want that as step 2 because some of the information in volume 3 does use that, but volume 3 is deep learning, which is a little more, it has a better affinity map on Wikipedia, so to speak. Whereas, now I was not doing affinity maps when I first started this. These two books, the scores on that were considerably low. What volume 2 linked to was genetic algorithms, I can never say this word, cellular automata. I always want to say cellular automa, but in those pages, they're neat technology, but just not seeing a lot of current research. And you can see that here. This is just something I was playing with a few days ago. I posted this to LinkedIn, and it was kind of interesting. I did the first one, which was very current topics. Big data is a moving target. Caused all kinds of discussion. It's kind of funny. People are like, some of them are, and this is just social media. Some people are like, I don't agree with what you call big data at all. And some other people, I don't agree with Target. And one guy was even, I don't even agree with how you define a ISA relationship. But okay, so that is the really cool thing about the internet. If you don't like one definition, there's probably 10 others. Just Google it. So and by the way, I define big data sort of as data that is big enough that it is a pain in the neck to deal with. That's why it's a moving target, because computers are getting better. It's a question of, are the computers getting better, or is the data getting bigger faster? And the data that you care about. And data seems to be winning the race so far. Then I did another one. So if you notice, 182 likes. Then I promoted the second book, which was I wrote an article kind of about it, what nature can teach us about data science and artificial intelligence. Like I said, this is an area that I consider an important step, but it's not a hot buzzword. It's not what IBM Watson is using to beat humans at chess and medicine and everything. So that's just a quick sort of, and I did that sort of as just a comparison of those. By the way, another way you can easily get any sort of a viral is you pick any technology, big data, data science, Facebook, and the title is, insert that technology is dead. And then you go on to explain the Gartner hype cycle, which is basically that every new technology is just in the stratosphere at first, and then we go into this trough of disillusionment. And I mean, how many times have you seen Facebook is dead? The company, but anyway, that is. And then I also did some word analysis, like on Kickstarter. Teach your kid to program is very hot. There's one that was Project of the Day right now by some MIT people. Big data is very hot. So one, I was telling my wife, who is here, next book, if I just wanted to be a total keyword, I'm not going to say the not nice word, sellout, is, I would say, big data for little kids. Wouldn't that be cool? Even got the opposites going on. I'm not going to write it. If anybody wants to, go for it. But I mean, that would be teaching your kid to run up bills of thousands of dollars on Amazon EC2. Nah, you don't want to do that. So that's it. That is my experiences with Kickstarter. Yes.
Do you think, like the nature algorithms, do you see stuff coming back in vogue? It's just matter of time.
Well, what I really like about the nature-inspired algorithms, nobody's just ever made it work, compared to the statistical models like gradient boosting. I use gradient boosting a lot, which is awesome. It's a very good general purpose, very modern algorithm for that. You're fundamentally just adjusting coefficients. So you're creating a program that fundamentally is just going to fit the data better. It's not learning how to learn better. It's not inventing another algorithm. It's not evolving into a different algorithm, whereas some of the genetic programming stuff, you basically represent the entire program as a tree. You create a bunch of programs to solve it, often starting with sort of you engineer ones and put them out into the population. So that's one thing that I do. Nobody's ever made it work particularly well, but the idea is, the promise of genetic algorithms and genetic programming is nature created us this way, so all we have to do is get that base algorithm working and it'll evolve to that. So I actually rather like these. My affinity mapping is based on genetic programming because I don't want to figure out how to figure out the similarity between two documents on a knowledge basis. So I am a proponent of them. But in terms of current media buzzwords, which is what my research sort of led me to, they're not predominant right now. I like support vector machines. I often use, yes. It's not something I've tried. I mean, the support vector machine is very much an input of quantitative data. So I have to do a bag of words or some other more complicated way of representing. Yes. Stretch goals, I don't think I personally do them that well. What I usually do with stretch goals is my books are language agnostic. So I just write about the theories and then I create examples in various languages. So what I've had the most success with on stretch goals on my own personal projects are additional programming languages. But that's something I'm looking at other projects and trying to think of. How can I introduce some sort of scarcity and also get the stretch goals going as well? Well, typically what you would, I mean, if I wrote the author of the first paper and said, well, hey, what about my project? He would probably call me an outlier, and outliers are very important to, it's a very important part of data analysis and statistics is finding out what they are. They are basically things where something bizarre happened and you just don't even want to try to predict it, because if you can predict 90% of the cases and identify those 10% that you just don't even know, that's useful. But there's really nothing that I can see that they could have predicted what that first project of mine would do. They'd be like, well, it's a slow start. Unless they could do sort of, if they would have done, that's where the project affinity mapping that I was doing might have told them something. They could realize, okay, this is a hot topic. This has potential. That Jeff guy just does not know how to get the word out. So that's the closest I can rationalize it. Yes. How I used WordNet is essentially what I am doing is this is where I'm using genetic programming. I feel like I'm almost anti-selling my second book. It's just not in the public buzzwords that everybody likes, but contrarianism is good. So, but anyway, the way that works is I basically am using the typical sort of tree that you have in genetic programming, where each node on this tree it can be an equation, but I have more nodes than that. So you give it a set of tools to work with, and those tools tell it how to build other trees, and it basically builds trees up and this is common in natural language processing, of the two documents that it's trying to compare. And then it compares the two trees. And there's all sorts of ways to do those comparisons. So I'm largely just giving it the tools to build the trees. WordNet is useful because maybe you don't necessarily care about the difference between, I don't know, a word processor and a spreadsheet, but it might roll those up to say that, well, they're both computer programs. So it just gives it an additional level of abstraction. So that is what I use. That's what I use WordNet for. I use it primarily on the nouns to just give an additional level. And I largely just give it those tools to work with and and then I usually bound the domain of Wikipedia, because the problem is when you're doing a genetic algorithm, the longest part of this is the evaluation, where I've got to sit there and go over Wikipedia. So there's a variety of things. That's the gist of it. Yeah. That's a really good observation, and one that I have not gone down, and nor did the other. She did the author of the original paper did do some analysis on words that seemed to sort of damage a Kickstarter, but that's a very common bias that is introduced in particularly in stock market analysis, because companies that go out of business drop out of the stock index and you tend to not notice them. So if you think about it, if I'm doing an analysis across all of the Fortune 500, well, I'm looking at the companies that exist as of today, not the ones that dropped out over the last. So if you're doing an analysis on the data of the Fortune 500 over the last 5 years, what you're really doing is analyzing the survivors. So you have to be very careful about those sort of biases, and that's a very good observation. I just have not gotten to that point yet, but I do intend to analyze the losers as well as the winners. Yes? It's about 50-50. Yeah, it is really about 50-50. I have not seen statistics by category. I think by and large and usually you can tell very quickly. It's just the inability sort of to even get the word out to even get to the first level. That's a good point. That is a good point. So the predictive model, I guess my only so if you're just predicting success, you're right. It would not be an outlier because it did succeed and it just did even better. The reason I guess I call it so outlier is very much by the context of what you're analyzing. It is very unusual in that very rarely do they sort of hit that point and go. It does happen. I've seen other ones. It would be interesting to do to write a query in Mongo and actually find those and look at them. But that's a very good point. Deeplearning.net. It's not by Jeffrey Henkin, but it is by, I think, some people very closely affiliated. I cannot pronounce the guy's name offhand, but it's a very good and deep learning is very, very good for sort of unstructured and like computer vision, robotics sort of things. It's really good for that. For more quantitative data science, like you use in my particular industry, you're using generalized linear models and gradient boosting, very popular, and other things like that. Boosting, by the way, is a very cool algorithm that has the idea of a lot of these algorithms are weak, but together they become strong. It's like putting a bunch of sticks in a bundle. Yes?
Is that kind of a first
Absolutely. I know it's very common for programmers to fall in love with one particular programming languages. Monogamy in computer programming is highly overrated. So I like to use whatever tool is good for the particular task at hand. So Python is great mainly because there's so many statistical packages written for it. I mean, that's really its strength. Similar strength with R. As an actual programming language, I like Python a lot better than R. R feels a lot more hacky to me, but I know other people who prefer R. So Java and C#, yeah, my current books will have all the examples in those two languages. I consider those to be sort of the mainstay languages of IT right now, so they're very important languages. You would just end up either writing your statistical model from scratch or finding a like a support vector machine on the internet, using it. Okay, now I want to do gradient boosting. Okay, that's a different model. And oh, by the way, I've got to now rewrite a lot of my interface code to make use of it. So that's kind of the strength of Python. I found out too on my first book with the stretch goals, Python was the most requested language and C was the second. So and then I don't know where Java and C# would have landed because those were the given ones.
And with the files
Okay.
to C.
Yeah, and I mean, anytime I've not played with Python. I almost want to call it Cylon, which would be another whole rise of the machines. But yeah, I see a lot of promise for Python. It seems, in the scientific and data science community, it seems very big. I've only been doing Python for about a year. One thing that helps too in my books is I get people from the community who help me to translate these to other languages, and that is really, really cool. Even if in Python, you basically, they have the word Pythonic. Python, on one hand, is the most readable language in the world until you try to make it quote-unquote Pythonic, because if you know the right voodoo Pythonic magic, almost anything can be reduced to 2 lines, which is kind of interesting. But I'm overstating just slightly. Yes? Mm-hmm. I would really just as soon not write a HTML parser in Python. If I can use one of them, that's great. You always want to make sure you attribute to whoever uses it. You have to be careful that whatever you're using has support. A site that I really, really like for that is called Olo. And OHLOH, OHLOH, is awesome. If you ever want to know if a particular because what you want to know with an open source project is, does this have legs? Is it supported? Is this going to be gone in a year? And it does some kind of data science-y sort of stuff, not too heavy, but it just shows you what's the commit history, how many authors do they have on there. So like Incog, there's actually 25 people other than me who have contributed code to it. So that's one thing you want to look at is how many people are using it, that sort of thing. So I do try to pay attention to that. Now for this, I don't care if Beautiful Soup is gone next year because I probably won't be using this code and they will probably redesign Kickstarter and all my fragile scraping code will be broken. Yes. What I was able to do there is you can post a project update forever. So I was able to post a project update to the first project and say, hey guys, here you go. And that got me a lot. I mean, that got like a couple $1,000s in backer money just almost immediately. And of course, with AI and any other sort of thing that people are doing as a hobby and they've got a day job, they come in and out of the particular interest. So I definitely did not have 100%. I don't have the data yet to form those statistics, but that's something else I'm very interested in seeing. Because once my project reaches the end, then I have access. I can pull down all the CSV files of my backers to fulfill stuff. Yeah, one last question. Yes?
Where, if anywhere, did you use neural networks in your analysis?
On this particular project, nowhere. Experimenting with some deep learning on the Wikipedia analysis, so that would be a type of neural network. Okay, and I did bring 3 copies of my first book, so I'll give those away. The way I usually do this, rather than I don't have access to the internet at the moment, no random. Does anybody have a birthday this month? All right, you get one. You too? And absolutely, yes, perfect. That makes it easier. It's more difficult when you have to go into the next month. Thank you very much.
Awesome. That was good because we're trying to get for our next meeting